Danfoss ICV control valves are part of a modular platform concept offering one platform for multiple control solutions. Common bodies are available for ICS pilot, ICM motor-operated, ICLX two-step solenoid valves with interchangeable function modules and top covers, easily used actuators, pilots, digital stepper motor. To learn more, visit our website www.danfoss.com/ICV. Servo position and pilot piston is closed, ICAD 0%. ICAD is opening. ICAD turns spindle, which lifts up the pilot piston. Pressure escapes from on top of the piston assembly. Servo piston gets out of balance. Pressure forces the servo piston to move upwards. Refrigerant flows through main port, a pressure balance on both sides of the piston assembly occur. If ICAD encounters a higher resistance from the ICM valve, the displayed opening degree on the ICAD and the ICM mechanical opening degree gets out of synchronization. The higher resistance could come from dirt in the system, sticking surfaces after long time standstill, or the extreme situation where you have a foreign body in the ICM valve blocking the regulation. This means that in an extreme situation, when the displayed opening degree on the ICAD is 0%, closed, but the ICM mechanical opening degree is actually to some degree open, having an encoder included in the ICAD eliminates this risk of ICAD and ICM valve not being fully synchronized. Our expert will create several simulations demonstrating benefits from having ICAD with included encoder. Let's observe Simulation 1. Where ICM and ICAD are operating under normal conditions. ICM valve opens and closes as the input signals changes. ICM valve opening degree corresponds with the opening degree value on the ICAD display. ICAD carries out oversteps to ensure ICM valve is closed. Now let us simulate a rare situation when foreign body gets into the valve opening, preventing it from closing. Simulation number 2, ICAD ongoing regulation with resistance in valve. Valve opens and closes as the input signals changes. ICM valve opening degree corresponds to the opening degree value on the ICAD display as long as it does not meet resistance that the ICAD cannot overcome. When ICAD without encoder meets resistance, it will not be able to register the fact that the valve seat is not moving, and the ICM valve and ICAD will be out of sync. When ICAD with encoder meets resistance, it will detect the resistance and keep track of ICM valve position. Input signal is decreased from 73% opening degree to 20%, but meets resistance at 49%. ICAD without encoder will display the new requested opening degree of 20%, but the ICM mechanical opening degree will be 49%. ICAD with encoder will display the new opening degree of 49%, the same as ICM mechanical opening degree of 49%. Let's continue observing. Input signal is changed 0% or closed. ICAD without encoder will display 0%, but the mechanical valve opening degree is not closed. ICAD with encoder will display 0%, and the mechanical valve opening degree is exact the same, 0%. With encoder included, the ICAD and ICM is always in sync and represent a true valve feedback. Third simulation will demonstrate the value of A9 alarm functionality. Valve opens and closes as the signals changes. ICM valve opening degree corresponds with the ICAD opening degree value in the display as long as it does not meet resistance. When ICAD without encoder meets resistance, it will not be able to register the fact that the valve seat is not moving, and the valve and ICAD will be out of sync. When ICAD with encoder meets resistance, it will keep trying to reach requested opening degree for 15 seconds. If this is not reached, an A9 alarm equals valve blocked will be given. As you can observe, the encoder function, now becoming standard for Danfoss ICAD actuators, will give a very reliable operation at harsh conditions, providing a safe valve position feedback. For more information, visit danfoss.com/ICV.